What's up? I'm Vin, and today I want to show how to write the equation of a line, and I want to look at all the cases that you could run into. Now, here are some formulas that are helpful, so if you don't have these in your notes, just take a moment to write these down, and now let's get started. All right, so question one, write the equation of a line. We're going through this point with this slope, and this is a very common type of situation you could run into. And the formula you're going to want here, when you're given a point and a slope, use the point-slope form equations. You have y minus y1 equals m times x minus x1. And now here, just make sure you understand what each piece means. Notice we were given the point 2, 4, so this piece here would represent x1, and this piece here would represent y1. So when we want to plug into this formula, make sure that you're plugging in for x1 and y1. Don't plug in for x and y. It's better to replace these two so that at the end we could have a nice equation in the form y equals mx plus b. So now we plug in. We have y minus y1 is equal to 4 equals the slope is equal to 3. That's our value m. And then we have x minus x1 is equal to 2. So we could stop here, but I'm going to write our answer in the form y equals mx plus b. So I'm going to distribute this 3. And we've got 3x, and then 3 times negative 2 gives us negative 6. So we have y minus 4 equals 3x minus 6. And now just do plus 4 on both sides. And here's our equation. We have y equals 3x, negative 6 plus 4 will give us not plus, it's going to give us minus, is going to give us minus 2. So here's our first equation. Now to check your answer, you always want to do a little mental check before you move on. See how I almost made a little adding mistake there, so definitely helps to check. Is I would plug in the 0.24. So if I replace y with 4, is 4 equal to 3 times x equals 2 minus 2. So we want to make sure this checks out, and it will. We have 4 equals 6 minus 2. 4 equals 4 is a true statement. So this checks out. This point is definitely on our line. Now, an alternate way to do this, and I'll go through this quickly, is some students take the equation y equals mx plus b, and what they do is they plug in for x, y, and m. So if you replace y with 4, m with 3, so we have 3 times x equals 2, plus b, this method also works. You have 4 equals 6 plus b, and then if you subtract 6 on both sides, this tells you that b is equal to negative 2. And then once you know what m and b is, you could plug into this equation, and it would give you the same line. So this is just an alternate way, but we can also use the point-slope form equation, and I actually prefer to use that one more. Now in the first example, we had nice numbers, but now let's say we have negative values, and we have a negative slope in the form of a fraction. So once again, we still have a point and a slope, so using this equation here, the point-slope form equation, makes the most sense. We have y minus y1 equals m times x minus x1. And now here, the value 4, our x coordinate represents x1, negative 3 is our y1, and m, our slope, is negative 1/2. So a little mental shortcut that I use is that when I'm plugging into this equation, what I do is I take the opposite, and we'll just say this out here. I take the opposite of each coordinate. Okay, so this is just like a little trick so that I don't make the mistake of missing a minus sign or changing the sign the wrong way. So what I mean by that, I'll show that in the next line. We have y minus y1 is negative 3 equals the slope is negative 1/2. And then we have x minus x1 is equal to 4, which we just plug in. But notice on the left side, I have y plus 3 equals, and I'm going to show this in a few steps so that you can see this mental shortcut. What I do is I take the opposite of each coordinate. So when I look at positive 4, I'm writing x minus 4, the opposite of positive 4. And then next to y, instead of minus 3, I take the opposite of minus 3, which would be plus 3. So this little mental shortcut allows me to go right from this step. So I go right from here to here. I essentially just skip this step using that little mental shortcut. So just something to be mindful of. And now here, if we solve this out, we have y plus 3 equals, and now we're going to distribute this negative 1/2 x. I'm sorry, we're going to distribute the negative 1/2, and first we'll have negative 1/2 x, and then negative 1/2 times negative 4 is going to change to positive, and then half of 4 is 2. So that brings us here, and then now we're just going to subtract 3 on both sides. And now our final equation here, we're going to have y equals, and we've got negative 1/2 x, and then we have 2 minus 3 giving us minus 1 here. So here's our equation. And once again, it always makes sense to just plug in real quick to check. So y is -3. Is that equal to -1/2 times x equals 4 minus 1? And then this gives us -3. If I do -1/2 times 4, that's -2. And then we have -1. And -3 equals -3 definitely checks out. So this was our check. And this line is good. So the next situation you could run into is sometimes you're just given 2 points and you want to write the equation of a line that goes between these 2 points. So when you get a situation like this, what you need to write the equation of a line, just know that you need 2 things to write the equation of a line. You need a point and you need a slope. So in this situation here, notice they gave us 2 points. So we have an extra point. However, we don't have a slope yet. So the first order of business is going to be to find the slope between these 2 points. So this one, let's say I call x1, y1. And then the second point I'll call x2, y2. And our slope here, m, we could say is y2 minus y1. So I have 9 minus -3 over, and then I have x2 minus x1. So I have 1 minus -2. And this is going to work out. 9 minus -3 will make 12 over 1 minus -2 makes 3. So our slope between them is equal to 4. Now, some students sometimes get tripped up here and they say, well, how do I know which one to make x1, y1 or x2, y2? And as it turns out, it doesn't matter which one you start with as long as you're consistent. We could have just as easily have done -3 minus 9 first and then divided by -2 minus 1, and we would have gotten -12 over -3, which equals +4. So we would get the same slope either way, but just know, once again, it doesn't matter which order you start with as long as you're consistent. If you make this x1, y1 and this x2, y2, just make sure you use the formula correctly. So now that we have our slope, the next thing students will sometimes struggle with is they say, all right, I have my slope, but which point do I use? Do I use -2, -3, or do I use 1, 9? And as it turns out, it doesn't matter which one you use. So next, we're going to use that point slope form equation. We have this equation here. And once again, it doesn't matter which one you choose. I would probably go with the second point because it's all positive. So it's less likely that you're going to make a adding or subtracting mistake. But once again, it doesn't matter which one you use. So what we have here, let's say I use this x1, y1. I would have y minus -3, and y minus -3 will change to y plus 3 equals, and the slope we found was 4. And then we have x, and then the opposite of -2 is +2. So if I do x minus -2, it becomes this. And now if we distribute, let's see what we get. We have y plus 3 equals 4x plus 8. And now we could subtract 3 on both sides. And we'll write our answer over here to the right. So our answer will have y equals 4x plus 5. So here's our line. But once again, it doesn't matter which point we chose at this step, because let's see what happens if we would have used x2, y2 instead. We would have had y minus 9. So y minus, let's say we use 9 here, and then our slope we found to be 4. And then we have x minus, and let's use this x value 1. And if we distribute here, let's see what we get. We have 4x minus 4, y minus 9 equals. And if we add 9 to both sides, check it out. We have y equals 4x plus 5. Same answer. This question here is so easy that it's difficult. We have this point and we have this slope. But one thing to be mindful of is that anytime you have an x value of 0, what they really just gave us, if we have the point 0, -5 down here, this is the y-intercept. So anytime you're given the y-intercept, we could be what we could do is we could write the y-intercept down as our b value. Our b value is -5 and our m value is -2. And we have this equation, y equals mx plus b. That's our slope-intercept form. And all we have to do to get our equation of a line is plug into this. So we're going to have y equals -2x, and our b value is -5. So here's our equation with very little effort here. Now, we could have also used the point slope form equation, but once again, anytime you're given the y-intercept and the slope, this formula is very easy to use. Now, sometimes you're given a graph of a line and you have to write the equation from the graph. So what we have here is we're writing the equation based off this graph. And notice what we have here. We have a vertical line, which is in the form of x equals, and I have k sub 2 here, but k sub 2 just represents some constant, some whole number. So what we have here is that it's going to be x equals, And where is this line hitting the x-axis? It's hitting the x-axis at x equals 4. So that's going to be our equation x equals 4. Now, sometimes students mix this up and they write y equals. And their thinking is, well, since the y-axis is vertical and this line is vertical, shouldn't this say y equals 4? But I'll show you why that's a misconception. So let's say I highlight this point. That's the point 4, 0. And then if I were to go up here, this is the point 4, 2. And down here, this would be the point 4, negative 2. And ultimately, an equation describes something that every point on the graph has in common. And notice every point that I look at here, let's say I look at this point, 4, 5, what do all of these points have in common? Well, notice all of them have an x coordinate of 4. Their x value is equal to 4. So that's why this equation captures every point on this red line here. Now, some extra details here to help you understand the theory of vertical lines. I'm going to draw out slope guy. Now, slope guy is just a guy that helps you understand all of the different slopes you could run into with lines. So a positive slope, lines go up, they increase. A negative slope, lines go down. In a vertical line, the slope is undefined, and with the horizontal line, the slope is 0. So if we look at this vertical line here, and let's say I pick any 2 points. If I were to pick, let's say 4, 5, and 4, 2. So I make this my x1, y1, and I make this one my x2, y2. If I were to try to find the slope here, m equals, and we have y2 minus y1, so we have 5 minus 2, over x2 minus x1 is 4 minus 4. Notice what we get 3 divided by 0, and 3 divided by 0 is undefined. And what this tells us is that since we have an undefined slope, we would not be able to use any of these equations here to write the equation of our line. We couldn't have a y equals equation here, so that's why it has to be an x equals equation. Okay, so we have an undefined slope when our slope is vertical. But if we bring slope guy with us to the next question, let's see what happens when we have a slope of 0. Well, looking at slope guy, when we have a 0 slope, we should have a horizontal line. And if we have a horizontal line, our equation should be in the form y equals a constant. So if we're writing the equation of a line that goes through this point with a 0 slope, then we're going to have y equals, and we just have to match the y value to our point, which is going to give us y equals negative 4. So for some of these questions, if you really get the concept, you could be done very quickly. But let's say we just didn't see that concept right away. Well, what we could do is we could use the point slope form equation once again, and watch what happens. If we use this, we have y minus y1 equals m times x minus x1. We have y minus, and let's say we call this x1, y1. We have y minus y1, so we have y minus negative 4 equals, m is equal to 0, and we have x minus x1. But now multiplying by 0 just wipes everything out. So we have 0 on the right, and on the left we have y plus 4. And if we subtract 4 on both sides, notice it gives us this equation here. We have y equals negative 4. So the last case I want to look at is when you're given a graph of a line and you have to find the equation of a line just based off its graph. And notice here that this is not a vertical or horizontal line. It has an actual non-zero slope. So what we do here is, there's a few ways to go through with this, but I like to think of slope. When I'm thinking of slope on a graph, I like to think of slope as rise over run. Now, I would never write this on a test, m equals rise over run, because that's not proper notation, but I can think it. They can't take points off for how you think. So looking at this, if I count the rise, notice the rise, if we count the boxes, we're going down 1, 2, 3. So my rise is negative 3, and then I have to run. I go over 1, 2, 3, 4, 5. So my slope, m, is equal to negative 3/5. And if we think about slope guy once more, forgot to bring him with us, but he's pretty easy to draw. If we think of slope guy, notice we have a slope that's negative, and when we have a negative slope, the line should be dropping. So when you're doing this rise over run method, just know that if you understand the concept that our line is decreasing, so our slope should be negative, that should help you stay accurate when you're actually counting rise over run. Let's say instead by mistake you had 3 over 5. You know your slope has to be negative because the line is dropping. So now once we have this, I want to use the formula y equals mx plus b, because we already have the slope, but using this formula we just have to identify the y-intercept. And if we look at this graph, notice that we're hitting into the y-axis at a value of 3 here. So our b value is equal to 3. So now that we have this is going to help us write our final answer. We're going to have y equals, our slope is -3/5. Now we just tack on our x, and then we write our b value. We have +3. So here is our equation.